All right, so again, today we're going to do test review, and then when I see you again on Wednesdays, your test, again, 2 devices, make sure that you're logging in from the second device. Please don't waste the time getting on the iPad and then like, oh, I got to switch, and then switching. Try to get in at when you can, on time, and from your second device. And then you'll take your test on Wednesday. It's only 8 questions, but 2 of them have multiple parts. Those are the ones we're going to practice today. You definitely need your calculator. If you haven't figured out your scientific calculator, today's the day to do that. At the end of class, we can talk about it. And then on Friday, we're going to do 10-1, which is like 3-dimensional points. So we'll start it on the Zoom meeting, but depending on how long it takes you guys to get in there, sometimes it takes a while. You may be finishing the notes over the weekend, and then we're going to do 10-1. We're going to skip 9-6. I had a conversation with Mrs. Boyd, and we've agreed what we should cover is more of the review chapter. So that's the good thing, is that what's left is mostly review. Besides 10-1 will be new to you, but other than that, it's review of some Algebra 2 skills, pre-calc skills to get you ready for next year, and that will be where your last assessments come from. So your last quiz and your last test are going to be from that information. There we go. Make sure Mary Angel got it. Yeah. Hang on. Sorry, I got to turn my volume up. Say that again. Okay, just tell her she can watch the video. I know mine flickered out yesterday. Yeah, just no worries. Okay, and then Valentina, you said question 97, right? 97. And what was the other one? Review the chat. Yeah, okay, I got it. Okay, so these solutions are on the assignment, but I'll go through these. 97 says, plot the point given in the polar coordinates and then find 3 additional polar representations using negative 2 pi to positive 2 pi. So if it's negative 11 pi over 6, right? So if I had my unit circle in front of me, I know like 11 pi over 6 goes goes clockwise all the way around to the last over 6 that you're going to hit, which is actually the same thing as pi over 6. And then I'd go negative 2, which means you have to go in the opposite direction, 1, 2 rings, and you'd plot your point there. So that's the first thing, the plotting of the point, negative 2, negative. Haley, you're in here, right? Yeah. I just got your email. It's so weird. It literally just came through. I wonder how big of a delay is this. Okay. Anyways, and then you wanted to find the additional representations, right? So I would take those points. Remember, you have 2 options. Leave the r as it is and add and subtract 2 pi, or change the r to negative, the opposite sign, and then add and subtract just pi. So if I add 2 pi on here, which would be 12 pi over 6, I end up with 11 pi over 6. And that falls between, I end up with pi over 6. And that falls between negative 2 pi and positive 2 pi, so I can keep it. So keeping the r the same, adding the 2 pi gives me that one option. Then I would try it again. If I add 2 pi to it now, it's going to be too big. If I take this and add 2 pi to it, if I take the original one and subtract 2 pi from it, it's going to be too small. So that means I have to use the other process, which is change the r to be negative, add and subtract pi. So if I take a negative 11 pi over 6 and I add pi, it'd be 6 pi over 6. I end up with negative 5 pi over 6, and that's in between negative 2 pi and positive 2 pi, so it works. I can't subtract pi over 6 because I can't subtract 6 pi over 6 because it would be too small, but I can and take and add another pi over 6 to this. Or actually I would add, I don't know what's the answer. From my original angle, which is 11 pi over 6, you're adding odd multiples, so I would add 3 pi, which would be 18 pi over 6, and I'd end up with 7 pi over 6. And there's the last option, 7 pi over 6, right? 7 pi over 6 would be, and it would be positive. These would be positive 2s. 7 pi over 6 is here, go to 2, negative 5 pi over 6 is there, go to positive 2, and then this is the one that would be negative because you'd go to positive pi over 6 and work your way opposite. So your 2 options again are to either keep r the same, add and subtract even multiples of pi, or change r to be the opposite sign and add and subtract odd multiples of pi. You good on that one, Valentina? Oh, because instead of adding just pi, right? I added pi, and that was a point that was in range. But if I subtract pi, it's too small. So instead of adding pi, you're adding odd multiples of pi. The next one would be 3 pi, which would be 18 pi over 6. Does that make sense? Yeah, okay. All right. So then 103 says 2 and negative 5 pi over 3. Again, you're doing the graph first. So negative 5 pi over 3 goes past 1.5. It goes all the way around to where pi over 3 would, which is actually here. Pi over 3 would be here. And then you're going to 2. So you're going to your second ring, and there's your point. And then it said to find the rectangular coordinates for it. So remember, if I'm going from polar to rectangular, that I have to do r times the cosine of theta and r times the sine of theta. So it'd be 2 cosine negative 5 pi over 3 and 2 sine negative 5 pi over 3. And then that 5 pi over 3 is going to be again on this point, which is a positive 1/2 and root 3 over 2. So it'd be 2 times 1/2, and it'd be 2 times root 3 over 2. These cancel and I get 1, these cancel and I get root 3. So that would be the same point, but in rectangular form. So you'll have those questions with calculator, polar to rectangular, rectangular to polar, and without calculator, polar, rectangular, and rectangular to polar. So just make sure you know how to do both. Hopefully everybody found a calculator that's going to work for them. Yeah. Yeah, it's always the origin. Doesn't matter what the angle is. If the radius is 0, it's origin. Yeah. You probably won't get that on the test, though. Any other questions from the review? Mm-hmm. Oh, it just says use the graphing utility to graph. So you're just going to go make sure you're in parametric. Here, let me put this up there. My battery's about to die. All right, so it just said to graph it. So you want to make sure your mode is parametric when you're graphing like that. And then you want to go to your y equals. And theta is just your variable. So you can use t, it's the same thing. And then type in 6 cosine and 6 sine, and then hit graph. It didn't give me a window, so maybe I would have adjusted it like negative 10 to positive 10. There was no window to tell you. So it actually makes that circle. And you won't have orientation because your graphing calculator doesn't know the orientation. So you won't graph parametric on your graphing utility for your test. You're going to graph it by hand, which is what we'll practice right now. Yeah, theta's just a variable. So you can keep it as t, because if it's in parametric, it's going to be t. No, not with the calculator. You're going to graph it, which is here. I'll show you that now. Okay, so go ahead, go to Canvas. Go. Okay, so let's start. 69 is your graphs, which is great because this is actually one of the things that we're going to just about to do, that we're going to graph. Okay, so you want to sketch the curve, and then it says, then eliminate the perimeter, write the response corresponding rectangular equation whose graph represents the curve. So these would be two separate questions on your test if you think about it that way. This is going to be your x, well, your t, your x, your y, and then your xy is going to be the first type of question, right? It didn't give you a parameter. I will give you a parameter because I want them all to be the same graph. It will be easier for me to grade that way. So let's say it's -2 to t to +2. Then it'd be -2, -1, 0, 1, and 2. And then you're going to plug those in. So -2 to the third would be 8. Negative 1 to the third would be 1. 0 to the third would be 0. 1 to the third would be 1. 2 to the third would be 8. Those are the x values. Then y 1/2, y negative 2 squared would be 1/2 of 4, which is 2. 1/2 negative 1 squared would be 1/2 times 1, which is 1/2. 1/2 times 0 is 0. 1/2 times 1 is 1/2. And 1/2 times 2 squared would be back to the 1/2 of 4, which is 2. So then your coordinate points that you're going to plot are 8, 2, 1, 1.5, 0, 0, 1, 1/2, and then 8, 2. And then you will actually get a coordinate grid. The answer sheet's already there, but we'll talk about that in a minute. And you're going to plot these. So they should be exact. So 1, 2, 3, 4, 5, 6, 7, 8, 2, 1.5, 0, 0, 1.5 again, and 8, 2. So this is a repeated one. There would be like a cyclic thing here. So all you need really is that one curve, and then you need your arrows pointing towards the end. What happens here is this is actually one that has like a, because it's got a cubic in it and a squared, it's different than what we've done before, but it would have some sort of a pattern where it doubles back around. So as long as you're plotting the points that you, that I give you, you're good. And I didn't do a cubic with a squared. They're more, it's either going to be 2 lines or a line and a, which would make that parabola. Okay, so then the second part of this said to eliminate the parameter. So if I had to take these, and the goal is to eliminate one of them, right? So solve one of them for t. So it's hard because they both have to have some sort of a square or a square root. So let's say I take this 1/2 t squared. Let's say I multiply by 2, I'd get 2y equals t squared, and then t would equal the square root of 2y. So when you're plugging this into the other one, this would be to the third, right? Like that. Okay? So it's actually a 3/2, like that. To get rid of that, solve it for y, you'd have to do 2/3. And then divide by 2. So again, I went kind of easy on the, if you type that in your calculator, you would see a different kind of curve. I went kind of easy on these curves. There's not like a squared and a cube or anything like that. You might have to square root, but then when you plug it into the other one, you're not going to have to cube a square root or anything like that. So I would say, well, I mean, there could be a squared, but if not, 65 is a little bit closer. But we're going to practice these right now, okay? So if you go to Canvas, everybody needs to go to Canvas. If you go to Canvas and you click on quizzes, so I want everybody to practice this so there's no confusion with your test. I'm obviously not going to be able to walk you through this entire process while you're taking your test. You don't want to waste time for your test by not being able to answer because you didn't practice the process, right? So you're going to go to Canvas, you're going to click on quizzes. And if you go to your practice quizzes, you're going to see something that says today's 854, 55, non-graded 9.4, 9.5 practice. Looks like this. This is your answer sheet. So if you download this, you have options, okay? You can either take this answer sheet and you can download it to Notability. For today, you can practice that. You can print this out if you have a printer at home and you want to print it out so you have a hard copy. Or if you don't want to do either of those but you want the hard copy and you don't have a printer, you can just create, so take a blank piece of paper and create an answer sheet that's like this. So model it after it. It's super important that you have the rectangular coordinate grid, that you have the T-chart, and then you have the polar graph. So you want to make sure you have this. So either, again, open it in Notability because you're going to do your work there tomorrow, or print it, or take a piece of paper and make it look like this. Shh. Chickens are so loud. Shush. I have one chicken that's a freaking escape artist, and all she does is, hey, cluck, shush. All right, go, Emily. I'll unmute you. You're unmuted. You don't have an arrow at the top? Oh. Everybody do this from Safari. Sorry. Everybody go to Safari. Yeah, the upload didn't work for everybody in the app. So everybody go to Safari. You're going to do the same thing on Wednesday. You're going to do it from Safari. I'm glad that happened. Yep, from Safari. I should have said that. It says it in the instructions on the thing on Wednesday, but make sure that it's in Safari. Go ahead, Andy. I'm going to unmute you. There. Yeah. So there's 2 parts to it, and that's what we're going to practice today. So go, first of all, start at Safari. Let's make sure everybody can get this open. Start it in Safari. Send it to Notability. Try to ignore my chicken. Do you hear her? Or is it just me? You hear her, right? Okay. You're so loud. She was pecking my feet during a period. All right. How about now? We're getting it exported to Notability if it's from Safari? Yes. Okay. And there's a couple nod heads. Okay, good. All right. So send it to Notability. And then go to Start Quiz. So go ahead and... Well, mine's going to say resume, but yours is going to say Start Quiz. So these are not the exact same equations, but the exact same format as question 1 and 2 that will be on Wednesdays. The first one says, and it should say graph. Graph the curve represented by the parametric equations. Indicate the orientation of the graph. Given -2 is less than or equal to t, which is less than or equal to 2. Fill out the t-chart and plot the points on the graph. Okay, so let's start with that. I'm going to answer this question. We're back into Canvas. This is going to be the most confusing video on YouTube if you're following it because it's going to go back and forth. But hopefully we get the overall process. We've already graphed the question, okay? Now my answer, oops-a-daisy. Notice that it looks like an essay box where you would normally type an essay. What I need you to do is embed the image into your answer. This makes it so much easier for me to grade because I don't have to download your individual files. So if you look at your... Hey, I didn't mean to click on you yet. If you look at your options on the box above, you want to click on the little moon and stars. I keep doing it with my fingers. Hang on. You want to click on, not that one. You want to click on the one that looks like the little, sorry. You want to click on the one that looks like the mountain with the moon over it. That's the one you want to click on. That is Embed Image. Okay, so I'm going to click right there. Let's see if it's going to cooperate. Yeah, and you should get this box pops up. It says Insert Edit Image. Now listen carefully, because again, this could get confusing if you don't practice it. You're going to click on Canvas, not URL. You're going to click on Canvas. You're going to click where it says My Files, and all of a sudden the little thing on the box says Upload File now. It didn't say that until I clicked on My Files. So I'm going to click on Upload File. This is where my choice is. Do you want to upload it from your actual photo library, or do you want to take a file, take a picture? So if I had a hard copy of my work, then I would click on Take Photo, and I would take a picture of my work. There's my birthday list without Eric's name on it. I would take a picture, and then that's what I would upload. If you want to upload it from your camera roll because you just screenshot it from Notability, you just go to Photo Library, and you're going to pick that question, which is this one. Yeah. I'm going to click Done, and it's going to load that question as an answer. So the answer is actually a picture. I'm going to scroll to the bottom there and say Update. And it's going to put the question answer as that picture. Okay? Any questions on that process? Because that's how you're going to submit questions number 1 and number 2 on your test. Okay, so let's do number 2. Number 2 says, use the polar coordinate grid to graph the given point, then find 3 additional representations of the point using -2 pi theta to 2 pi. And my coordinate point is -3, 7 pi over 6. I'm going to click on the little mountain with the moon. Go back down here. I'm going to click on Canvas. Yep. Go ahead, Andy. Wait, hang on. Let me raise the volume. Go ahead. Okay. Hey, let me go right back to it. Okay, hang on just a second. So from this screen, I'm going to click My Files. I'm going to click Upload File. I'm going to go to my photo library, and I'm going to find that last question I just did. select it. Done. There it is, loaded into the answer for this question. Okay, and then if you're all the way done, obviously you're going to click submit quiz. You can, like, if you find that you make a mistake and you have time to go back and check it, you can always come in here and literally just delete out the picture and repeat that process. So once you put it in there, it's not that it's stuck. I mean, it will save it, but if you want to change it out, you can certainly change it out. So if I take x equals 2t minus 3, and I take y equals 2 minus t squared. Oh, you know what? I can't. Hang on. I'll have to screen it. I mean, I'll have to. All right. So if I took x and I plugged in the values that they gave me, which are going to be the same values, -2, -1, 0, 1, and 2, you're going to plug them in. That's in the pink. So I got -7, -5, -3, -1, and 1. And then I take the values and plug them in for y. I got -2, 1, 2, 1, and -2. Now I'm going to go to my graph. First of all, I fill in that last chart, right, which is the x, y coordinates. And then I go to my graph. -7, 2, 3, 4, 5, 6, 7. -2 is here. -5, 1 is here. -3, 2 is here. -1, 1 is here. 1, -2 is here. And then I'm going to plot my curve. So these could be curves, they could be lines, they could be any kind of shapes, depending on how we restrict it. And then I don't want to forget my arrows, my orientation arrows. Remember, they point towards the biggest T or away from the smallest T. We good so far? Okay, so now for this question, you are going to take a picture and submit only this question. So I'm going to take a screenshot. So you're going to do the same thing in Notability. You're going to take a screenshot. If you have a hard copy, I'll show you what you'll do when we get there. But for now, let's say you're working on Notability. You're going to take a screenshot of just this question. I don't care if like the tools and stuff are in it. Try to get as zoomed in as much as you possibly can so there's not a lot of extra stuff. But you don't have to stress about cropping it perfectly. I want to be able to see it clearly. -3, 7 pi over 6 was the question. So the first thing we're going to do is graph this. 7 pi over 6 is right here. But -3 is, instead of moving towards 7 pi over 6, moving away from 7 pi over 6. And there's my coordinate point, -3, 7 pi over 6. The button you're going to press to embed it is the one that has the mountain with the little moon over it. We're going to practice it again at the end of this question, but that's the one that you want to pull it into. Okay, so that's the first plotted point, right? But then it says find 3 additional representations of this coordinate point. So the first thing I can do is keep our... Josiah, are you in Safari or you're in the app? And you don't have that embed image option? Click on Canvas instead of URL. So when you click on the little mountain and you get that little embed image box pop up on the top there that says Canvas, because it automatically defaults to URL. Canvas, my files, yep, and then upload file. Got it. Good. Okay, that's why we're doing this today. Okay, so now from here I need to find my additional representations, right? So I'm going to keep R the same and then take 7 pi over 6, and if I add 2 pi to it, it's too big. If I subtract 2 pi or 12 pi over 6, I get negative 5 pi over 6. And that falls between negative 2 pi and positive 2 pi. So that's one of the representations that I can use to graph that same point. If you were to graph this on your unit circle, negative 5 pi over 6 would be here. Moving negative would mean moving it away, and it would be that same point. So that's how you can check it. Then I can't subtract 2 pi from it again. It's too small, which means the other option is to change the sign on R. Normally, if it's positive, we go to negative, but this one's already negative, which means we're going to change it to positive. And then take 7 pi over 6. If I add pi to it, it'd be 6 pi over 6, and that's 13 pi over 6. That's too big. If I subtract pi from it, I get pi over 6. That falls within my range, so there's a second representation of the same coordinate point, which should make sense. Here's pi over 6. Here's 3 pi over 6. That works. I still need one more. So remember, I can add and subtract odd multiples of pi, which means I can take that 7 pi over 6 and subtract, because if I add 3 pi, it's too big, but if I subtract 3 pi, or 18 pi over 6, I get negative 11 pi over 6. That's bigger than negative 2 pi, so it works. So 3 and that negative 11 pi over 6 is the last of the representations of this same point that would fall between negative 2 pi and positive 2 pi. So if this is my test, I'm ready to submit. I'm going to screenshot this question. That second question says,